Welcome to the office of Cedar Run Landscapes in North Wales, Pennsylvania. My name is Alden Zove. I'm the president of Cedar Run Landscapes, also known as the Rain Guy. During this presentation, we'll be taking you through step by step the design and execution of a rainwater harvesting system here in front of our office. What will be unique about this system is that we are going to be incorporating a permeable paver patio over the top of the rainwater harvesting cistern. The paver that we will be using is manufactured by the E.P. Henry Company, and it is called their Eco Cobble. The one that we will be using is their Coventry Eco Cobble, which is an aged paver. This paver is unique in that it will seamlessly integrate with both their Coventry 1 and their Old Town Cobble to give you many more design opportunities in the construction of your permeable patio. There are many benefits to capturing rain. One of them is the ability to utilize that rain for any non-potable outdoor uses. Here at Cedar Run, we have used tens of thousands of gallons of captured rainfall, both for watering our plants that we keep in our greenhouses, for washing our fleet of vehicles, and also for the topping off of our various water features that we have. This rainfall that is captured and used on site then slowly infiltrates back down into the water table, recharging the aquifers in our area, instead of quickly running off from the roofs of our buildings and then carrying with it suspended solids and the possibility of pollutants into the sewer systems and eventually into the streams and lakes around our office. The rainfall that has been coming off of the roof of our office has been causing erosion down our driveway, carrying with it some grit and gravel. We haven't been very happy with the effects of this because we do have a storm sewer drain just a short distance down on Horsham Road from our office. And you can see that in the storm sewer we have grit and gravel. Also, there are pollutants and trash that are being captured at the top of the storm grate, and this is one of the reasons that we want to capture, filter, and reuse stormwater. Right now I'm standing within the excavation of what will be our rainwater catchment area. On top of the sand that's on the ground now, we will be laying our geofabric, our 45 mil EPDM liner, another protective layer of geofabric, and then stacking in our water matrices. We'll have 30 water matrices in this area. On top of that, we will be putting a Merafi 140N geofabric and then layering in 22 inches of number 4 stone. That's a clean stone that will also add to the water holding capacity of our cistern. I would like to introduce you to two of our crew members who are instrumental in the installation of our rainwater harvesting system with permeable paver patio. First, Caitlin Dibble, our designer. She has taken basic ICPI specifications for a permeable paver patio and has enhanced them to allow us to construct our rainwater harvesting system underneath. William Stewart, our project manager, is ICPI certified, and he will be overseeing the installation of both the paver patio and the rainwater harvesting system.
Hello, my name is Bill Stewart, project manager for Cedar Run Landscapes. Here we're going to go over a couple of individual components of our rainwater harvesting system. We're going to be utilizing 3 different methods of downspout water collection. Our first here is a 12 by 12 NDS drainage box. Commonly available item. Your macro debris gets stuck here, and we also put a piece of metallomesh on the inside to keep any small particulate matter from making its way inside the rainwater collection system. That will tie then into this pipe. On this downspout, we're going to be using this Rainus inline filter. The theory behind this one, the water flows through the body and the debris gets collected on this screen and washed out through the front. So this is actually a self-cleaning system. This is an aquascape unit. Similar in theory to the NDS box, we have a grate on the top, and then we have a fine mesh screen on the inside for your particulate matter. The systems we display at our shop, we try to do a lot of R&D so we can figure out what works best and which is right for a particular customer's home. With the addition of our new 1,000 gallon rainwater collection system, we will currently be collecting 4,500 gallons of rainwater here at Cedar Run Landscapes. This is all rainwater that once would have ended up in our streams, lakes, and purely as runoff onto our streets. This system right here, for example, all used to run into this swale that ran right directly out onto the street and into the stormwater system. All of our rainwater systems have auxiliary pumps allowing us to use the water to wash our trucks, water our plants, and refill our water systems. Any rainwater that we don't use re-enters our underground aquifers through our permeable systems. Currently at Cedar Run Landscapes, we are saving approximately 52,000 gallons of water per year. Here what we're doing is installing our modified stone edge material around our pervious clean stone interior. Both of these different kinds of stone have to come up at the same time. So what we're doing is we separate them with a separation fabric. We have a rigid plywood in between. We add stone to both sides and we pull the plywood out, leaving the fabric inside.
This is their standard Eco Cobble, and here you can see the aged Eco Cobble with the distressed or aged edges. They fit together, leaving this gap of under a ½ an inch, which is ADA compliant, and this is where we will be placing our number 8 stone to allow for the water infiltration. Here I have one of the E.P. Henry Coventry stone, a non-permeable, and you can see how that stone integrates seamlessly with the new Eco Cobble. As you can see in our sweeping process, we're using the number 8 washed stone. What is happening is that not all of the stone is filtering down into the joints. The reason that we've selected the number 8 stone is that it is comprised of both 1/4 inch and ½ inch stone. The majority of the stone that is not being swept in is of the larger size, but what we are trying to do is to get most of the largest stones down into the joints, which increases our percolation rate.
After we're done sweeping in the gravel, we'll compact this surface one more time, then we'll repeat this process twice to make sure all of our gravel is nicely nestled in our joints. In this area, you can see what will become our water feature. You can see some of the plumbing installed already. In this area, we're going to have 3 basalt stone columns rising up in this area. They will be pulling water from the bottom of the basin, recirculating it and oxygenating it as it flows through them. This will help keep the water in the basin fresh and prevent stagnation. Also over here you can see our built-in overflow pipe. This is built into our number 57 layer of stone. We have too much water in the system, too much rain over a short time period. The water will flow into this pipe and then out the other end. After that, the water exits the pipe there, we will construct a rain garden to catch that water and allow it to re-enter into the ground.
The rain guy here. Over the weekend, the National Weather Service had said that we had received approximately 0.95 inches of rainfall in the North Wales area. We substantially completed our patio on Saturday, and we're catching all of that rain both off of the roof, which is roughly 415 square feet, and our patio, which is about 247 square feet. And let's measure how much rainfall we've collected. You can see that we have approximately 7 inches. So what this will show is that we have approximately 40% of the matrices filled right now, which is about 397 gallons of stored rainwater, water that typically would have fallen off of the roof, off of this patio area, and had gone down into the local sewers and streams, possibly carrying pollutants and suspended solids with them. What we've done is we've captured it here, and we'll be reutilizing that water for the various needs that we have at our office.